All right, so today we're doing the notes for 7-2, solving equations with variables on both sides. So number 1, we have Jackson solved a problem on his homework and cannot figure out what he did wrong. What error did Jackson make and how can he correct it? So to start, this is Jackson's work. It's not written on your paper. So go ahead and pause this and write this on your paper now. Now that you have it written on your paper, what I like to do with problems where you're trying to find an error is I like to solve them for myself. So I'm going to copy down this exact problem here that Jackson had to solve. So we have 4x plus 12 equals 60 minus 8x. If you notice in the way he solved his work, he went ahead and rather than subtracting underneath each number, he did it horizontally. I don't love that. I think it's easier for you to make mistakes. So I'm going to show you over here how I would solve this problem. So I'm going to start by subtracting 12 on each of the constants. So 12 goes away, and then I have 4x equals 60 minus 12 is 48. Minus 8x. Now I'm going to add 8x to both sides. I'm combining my like terms here. That goes away. Now I have 12x equals 48. I'm going to divide both sides by 12. The 12's go away. And I'm left with x is equal to, always if you need to, break out your calculator. 48 divided by 12 is 4. It's better to be sure than to guess. So I see that he obviously did something wrong because we got different answers, right? And so I'm going to compare our work. So first I subtracted 12 on both sides. I look here. Well, Jackson subtracted 12 here, but look what he did on the right side. He added 12. So that is where he made his error. If I continue and I look, he added 12, but then here he added 8x to both sides, which is correct, divided by 12. So that's the only mistake that he made. So what error did Jackson make? He subtracted on one side and added on the other. And how can he correct it? By changing this addition symbol to a subtraction symbol. All right, moving on to number 2. Solve the equation 55 plus 32/100 times x equals 39 plus 1 74/100 times x, and round to the nearest thousandth. So I'm going to go ahead and start you can start with your coefficient or you can start with your constant. It really doesn't matter. I wouldn't recommend doing both at the same time. So I'm going to move this 32/100 x over to the other side. So now I'm left with 55 equals 39 plus, I'm going to get my calculator, 1.74 minus 0.32, and I get 1.42. So 1.42x. Now I'm going to subtract my 39 from both sides because my goal is to get that x by itself, right? So I need to move this constant to the other side. Whenever I do 55 minus 39, I get 16. 1.42x. So now my last step, just a one-step equation, 1.42. I'm going to divide by that on both sides. And so 16 divided by 1.42, and I get this long number here, right? So what I'm going to do is, like I said, round to the nearest thousandth. So I have x is equal to 11.268 because this 6 rounds the 7 up to an 8. And I am done. Okay, moving on to number 3. Janet uses chapstick that is 3 inches tall and she uses 1/5 inch per day. Randy uses chapstick that is 2 inches tall and he uses 1/10 inch per day. After how many days will both chapsticks be the same height? So here we're going to have to write two different two different expressions and set them equal to each other. So Janet has 3 inches of chapstick, and she's using, so we're going to subtract 1/5 of an inch per day. Randy, on the other hand, has 2 inches of chapstick, and he uses 1/10 inch per day. So those are my two expressions. Now I'm going to set them equal to one another. I first need to go ahead and make this 1/5 have a denominator of 10. So I have 3 minus 2/10 x equals 2 minus 1/10 x. I'm going to start by subtracting 2. And I get 1 minus 2/10 x equals negative 1/10 x. I'm going to move my work up here since I'm running out of space. So I have 1 minus 2/10 x equals negative 1/10 x. I just copied it down. So that's the same. So now I'm going to add 2/10 to both sides. Those cancel. I'm left with 1 equals 1/10 x, and it's positive because negative 1 plus 2 is positive 1. I'm going to multiply by 10 on both sides. So I get 10 equals x. The reason I'm multiplying by 10 is because I'm multiplying by that reciprocal. So to answer the question, after how many days will both chopsticks be the same height? After 10 days. And we're done. Moving on to number 4 here. Solve the equation. So here I notice that I have a lot more going on. On the left side I have a constant, I have 2 coefficients. On the right side I have a coefficient and a constant. And so I'm going to combine what I can. I'm going to start I could start by combining these, but I kind of just want to move these over one at a time. Now that's a personal preference. You can do what feels right to you, but I'm going to start by adding 13x to both sides. That goes away. Now I have 104.2 minus 11.4x equals 26x minus 8. Now I'm going to continue combining the coefficients, and I'm going to add 11.4x. So now I have 104.2 equals, if I add those together, I get 37.4x minus 8. So now I'm going to add 8 to both sides, and I'm going to move my work over here. So if I add 8 to 104, I get 112.2 equals 37.4x. Now I just have this one-step equation. So to get the x by itself, I divide by 37.4. And I get x is equal to, get my calculator, 112.2 divided by 37.4, and I get 3. Typically, we would write our answer, I'll go ahead and write it to the side here, with x first. That would be better than what I circled here. Last one, number 5. So Landry mows 100 square feet of grass at a rate of 20 square feet per minute. Joseph mows 150 square feet of grass at a rate of 10 square feet per minute. How many minutes will it take them to mow an equal number of square feet? So this one is similar to the chopstick problem. Landry mows 100 square feet at a rate of 20 square feet per minute. So that's Landry, right? Because we're going to be deducting to see how long it takes him to finish, essentially. Because he has the 100 square feet minus the 20 square feet per minute. But then we have Joseph here that has 150 square feet of grass, and he mows it at a rate of 10 square feet per minute. We're going to set those two expressions equal to each other because we want to know when how many minutes it will take them to mow an equal number of square feet. So we're not necessarily solving for how long it will take each of them to finish. We're solving for how long it's going to take them to be equal. All right, so I'm going to add 20x to both sides. I get 100 equals 150 plus 10x. Now I'm going to subtract 150, and I'm left with negative 50 equals 10x. Now I'm going to divide by 10, and I'm left with x is equal to negative 5. Now we might be tempted to leave that as our answer or represent our answer as negative 5, but how many minutes will it take them to mow an equal number of square feet? It will take them 5 minutes. The reason I'm representing my answer as a positive 5 is because they've both used 5 minutes, right, in order to mow the same amount. That's why this is negative, but it's going to take them 5 minutes. We're representing it as a positive amount of time. All right, that is it. If you have questions, let me know. Look at the website to see what problems to do in the book, and then your homework is on the back of this paper, and it is lesson quiz 7-2.